All right, so here we go with this. So I'm going to go over part number 1. It's all the reactions that we did yesterday, just in word form here. And by the way, I still have those sitting out, the examples I did. It's kind of cool because the precipitate, and some of you noticed this yesterday, it drops to the bottom. It sinks to the bottom because it's a solid in that aqueous solution, so it sinks to the bottom. Okay, so I want to go over all of number 1 together, and then number 2 uses chemicals that we didn't have, and you have to think about it and piece it together in a similar way that we did here. Okay, now let's go ahead and let's go to this. On this is, I just copied and pasted this from question number 1, and it says identify the products. Also identify the precipitate, which precipitate is just a fancy word for what state of matter? Not solution, but other solid. Okay, so our solid. Then we want to write a balanced chemical equation to complete this process. Now, the one thing that I didn't do that I wish I would have done, and I did on my examples here, all of these things should have AQ for aqueous, because yesterday, remember, they all started out as solutions. They were clear. The only one that had color to it was the copper 2 chloride. But again, they were all solutions. All of these should be AQ. So what we're going to do, we're going to go one at a time. Okay, so this is our first reaction here on number 1. We had silver nitrate, and that was on table 1. React with sodium chloride. And anybody remember what did that look like when we? White substance. Yeah, white substance, and it looked like milk, right? Eventually, it settles out to the bottom, and you can see that in the test tube today. And then, how do we know what is the solid and what's going to remain as a solution or as ions there? We use this ion solubility, or what we call a solubility chart. And I don't expect you to be, again, a subject matter expert. It's not on the test, but this is helpful. Okay, now here's some key things. If it is soluble, it dissolves, does not form a solid. If it is what we call insoluble, it forms that solid. So we're looking for the item that forms the insoluble substance. Okay, I'll go a little bit slower on this one, and then we'll kind of speed up. But remember from notes, this right here is a double replacement reaction. So what that means is this. We are going to get our first positive substance, which is Ag, combined with our other or our opposite negative substance, so Cl. Now, I'm going to get the charts, or I know the charges, but if you want to look on your polyatomic ion sheet, this is where I'm getting all these charges. So if you look up Ag, silver, you'd find Ag has a 1+ charge, and you would find Cl, chloride, has Cl 1-. Okay? If we can piece these together and we swoop and loop here, what's my formula become for silver chloride? What is it? AgCl. Perfect. All right. Now, that's great. Again, kind of review there. What we want to know is this. Is this a solid or is this AQ? So we turn to our chart. We look up these things right here, the ions. They're all the negative ions. So we start here. Our Cl 1- was our negative ion. We find it on our chart, and we say, okay, if Cl is combined with most things, it is soluble, meaning it should be AQ, but you have to check the exceptions. So if this is an exception, it's going to take that yes and change it to a no. Okay? If it's combined with one of these 3 things, we have to flip the yes to a no. So we have Ag 1+, mercury 2+, and then lead 2+. Is Cl in our scenario combined with one of those exceptions? Yes. Okay. It's combined with Ag, which means no longer is it soluble, and now, and it sounds weird saying it's not soluble. That forms our solid. Okay. So if it's no on this chart, it's not soluble. That is our solid. And so this right here would be our solid. Okay. And I don't expect you to again, know all that, but we would form AgCl as a solid. Then we take our other ions and use purple here. We take sodium, which is the positive, and it's going to combine with NO3. Now, again, I get this from the polyatomic ion chart, Na 1+, and if you look up nitrate, you would have NO3 1-. We swoop and loop. What's our formula then become for sodium nitrate? Yep, I heard it softly, but NaNO3. Now, the key thing here is this. We take a look and we want to figure out, hey, is it solid, liquid, gas, or AQ? And so we start with our negative ion, which is NO3. And so NO3 up top here is right at the top. Now, if it's soluble, it's AQ. Is there any exceptions here? Okay, so it's yes, it's soluble, meaning yes, it is AQ. All right. So if it's yes, AQ, no, solid. Okay. Now, final part before we leave here, we got to do what to complete this reaction? What is it? Balance. Perfect. All right. So let's go through this. Let's use pink here. Ag, silver. How many do we have on the left? 1. How about Ag on the right? Okay, they're good. I like to keep nitrate as NO3 because NO3 and NO3 are kept together on each side. So NO3 has no parentheses. No parentheses, we said, is how many? 1. Again, NO3, no parentheses. So how many on the right? Still 1. All right, we're good. Sodium, Na. How many on the left? And on the right? And Cl on the left? 1. And sweet, we're balanced. That was a pretty easy one. Okay, so that would be our answer to the first part of post lab number 1. Questions? Okay, does anybody need this? No. Okay, so what I am going to do, this next one here, I added the AQ. If you could just do me a favor and type in parentheses AQ, that would be great. I'm going to go a little bit faster now that we kind of have an orientation here. I am going to do this. Our first positive, which is Na, is going to combine with NO3. Now, we saw this from the last example. Na has a 1+, NO3 has a 1-. We swoop and loop. What's the formula for sodium nitrate? Yes. NaNO3. Now, we have to look, and we start with NO3. NO3, it says it's soluble, which means it's AQ. Is there any exceptions to that policy there? No. So, yes, soluble, meaning this has to be AQ. All right. Then we combine our other items here, which is iron and OH. Okay. Iron, Fe, in this case here is a 3+ charge. OH is OH with a 1- charge. Now, be careful here. When we swoop and loop here, what is my formula for iron 3 hydroxide become? How many Fe? 1 Fe. How many OHs? 3. So it would look like this. EOH3. Okay, now we look up OH right here, about halfway down. OH, right now it is not soluble, so it should be a solid unless it is combined with one of these things here. So group number 1 is that first column. Is iron in the very first column on the periodic table? No, not that. Iron's not calcium. Iron's not barium or strontium. So because there's no exceptions, no, that means it is our solid. That is what formed in our test tube yesterday. Okay, last part that we have to do in this one, we have to do what? Balance. Okay, so we start out here and we do have to put some coefficients out in front. In A, we have how many on the left? 1 on the right. 1, so they're good for right now. I like to save O and H until the end if I can. So I'm going to skip that over. Fe, how many do you have on the left? 1 on the right. 1. And then NO3. This is where we start to flip some things around. NO3, outside of parentheses, we have how many? 3. Over here, there's no parentheses, so how many? 1. So what needs to go in front of the NaNO3? 3. Very good. Now, what did that do to our NAs by causing that, doing that? 3 of those. So out in front of NaOH, you got to put 3. Now, here is where I like to come back and see if we did this right. Okay. Right now, we've already counted those oxygens from NO3. So block those out. Don't count those. Right here, we have 3 times 1 oxygen that's just hanging out by itself. Over here, check this out. We have 3 times 1. So we have 3 O's if we block out our NO3. So right now, O is good. H, how many, because of the 3 coefficient, do we have on our left? 3. Again, that 3, because it's outside of the parentheses, counts. So how many H's do we have on our right? We have 3. Okay. So this right here, by putting 3 in front of NaOH and 3 in front of NaNO3, counts. All right. Questions? Does anybody still need this? Okay. All right. So moving on here. Again, we got 2 more left, and then we'll be close here. Okay. So first things first, what we're going to do is we're going to combine Na and we're going to combine NO3. Again, we've seen this, so I'm going to go really fast. Na, 1 plus, NO3, 1 minus. What's the formula for sodium nitrate? Yep, Na, NO3. Now, we find NO3. If it's yes, it's soluble, it's AQ. Is there any exceptions? Okay, so this, again, we're going to see this a lot, is AQ. All right. Now we combine our other or our opposite stuff here, PB and PO4. Now, PB here, PB in this case is PB with a 2 plus, and then PO4 with a 3 minus. So be careful here. How many PBs would we need if we swoop and loop? We need 3. Very good. So we'd have PB 3. And how many chunks of PO4 do we need? 2. All right. So we would have our PO4, and we would need 2 of them. Okay. Now, let me write that a little cleaner. Okay, so now let's balance. Oh, we probably ought to figure out what the state of matter is here. Again, what we do here is this. We look up PO4. If it's a no, not soluble, solid. Okay, is PB one of these exceptions? No, so because it's no, not soluble, it is our solid here. Okay, so I'll squeeze that in. That is our S for solid. That's the item that's sitting in the bottom of the beaker there. Okay, here we go. We got a balance. So we take this and we say, okay, be careful. Na on the left, how many do we have? 3. On the right, we only have 1. So what goes out in front of NaNO3? 3. Then PO4, you it as a block or a chunk, no parentheses, so 1. We got 1 PO4. How many PO4s do we have on our right? 2. So we got to backtrack. Now we have 2. Because of that 2, we have 2 times 3. How many NAs? 6. What do we need to do to that 3 now? Make it a 6. Okay. So this now becomes a 6 because we rerouted our balancing. Then PB. How many PB do we have on our left? We have 1. How many on the right though? 3. So what needs to go in front of PB and NO3 too? Very good. And then be really careful because NO3 is a chunk or a block. It's 3 times 2. So 3 times 2 is 6. How many NO3s do we have on our right? 6. So we're now balanced. All right. Questions? All right. One more and then we'll be done here. Okay. Okay, last thing here, copper 2 chloride and sodium hydroxide. Again, we're going to see this. We get copper 2 combined with our hydroxide. Copper is a 2+ charge. Hydroxide is an OH 1- charge. Be careful here, swoop and loop. How many Cus do we need? We need 1. How about OHs? Okay, so we would say this goes in parentheses. Now, gotta find state of matter. So we look up OH. A no, it's not soluble, means it's gonna form the solid unless Cu is in one of those exceptions. Is Cu in one of those exceptions? No. So this right here is our solid. Okay. Then we get this. We get our Na combined with our Cl. Na is a 1+, Cl 1-. What's the formula for sodium chloride become? Easy. Now, NaCl. We look up Cl. Yes, it's soluble, means it's going to be AQ, unless Na is one of those exceptions. Is Na one of those listed exceptions? No. So that means that this is AQ. Okay, last part here, and I'll finally let you free here, is this. We got to balance. Cu on the left, how many? We have 1, and on the right? Okay, good. Cl2, how many on the left? 2. We only have how many on the right? 1, so what has to go in front of NaCl? Very good. Okay. Then, where are we at? Oh, NAs. How many NAs on the left? 1, but what do we do over here on the right? We got 2, so in front of the NaOH, another 2. And then UOH has a block or a chunk, no parentheses. So right now we have 1 times 2 because of the coefficient, so a total of 2. How many OHs do we have on our right? Okay, so we are balanced. Any questions on this stuff here? All right.
Oh, that was pretty good. 40 right there. Really,